Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is the Multimap collection in C++. Before proceeding, make sure that you have already watched these other videos first. A multimap is the same as a map, except that multiple items are allowed to have the same key. Some multi-map functions are the same as map functions. You can construct a multi-map using default construction, initializing it from a literal, or by copy construction. Functions equal range lower bound and upper bound can query how the multi-map's internal representation divides the space of keys into segments. When querying the number of items in a multi-map, there is a faster empty function for when you want to test whether or not that size is 0. You can use equality operators to compare two multi-map objects. Passing a key to the find function will return an iterator to that item, or a null iterator if that key does not exist. Remove one item from a multi-map by passing that item's iterator to the erase function. Or you could use one statement to remove a whole range of contiguous items. Or you could remove one item by specifying its key. Insert a new item into a multi-map by passing a pair object to insert or emplace. Those two functions only differ if that pair object doesn't have the exact same item value type as the multi-map's definition, in which case insert would create a compiler temporary pair object for copy construction into the collection, whereas emplace would use a cast constructor. Instead of passing a pair object, you could also pass a multi-map literal or a range of iterators from some source collection. All of a multi-map's data could be assigned from one multi-map variable to some other multi-map variable. Like a map, a multi-map's internal representation uses a sort class to organize its items in order based on key. However, when a multi-map has multiple items with the same key, the ordering amongst them is not standardized. Thus, if you change the order in which items get specified, the equality operator might give unexpected results. Furthermore, when there are multiple items having the same key, the item accessed by the find function could be any of them. Because of that ambiguity, a multi-map does not even allow indexing by the CArray operator nor the at function. If you are removing items by passing a key to the erase function, then one call is enough to remove all items having that same key. Consider what happens if you try to insert an item that already exists, matching some existing item in both key and value. For a map, if you had tried to insert that item, then the map would have refused your request, skipping over your request. But for a multi-map, that insertion request always succeeds. If the item already exists, then another instance of that item is put into the collection, having the same key and value.